Okay, let's get going on this small little video here. Before I give you a lesson on simplifying radicals, and I said that any number under a radical that's not a perfect square is irrational. I've said that a whole bunch of times. We want to compare the difference using a calculator between a rational number, which is any two integers divided by each other. Okay? So you might say, but isn't 2 a rational number? Yeah, but the way a mathematician looks at it, 2 equals 2 divided by 1. So we can represent any rational number as one integer divided by another. Well, that turns out to be really important to understand the difference between this guy and this guy. So you might ask, why did I choose 1 over 7? Well, I chose 1 over 7 because that's a long repeating decimal. And it turns out that any number divided by another number, or in mathematical terms, any integer divided by another integer must form a repeating decimal. So we're very familiar with the easy ones, which we did in scientific notation. There's 1/2 equals 0.5. Oh, here's a nasty one. 2 over 3 equals 0.6 bar. And when we write it out to 100th, we often write that. Why do we do that? Because we're telling us that the 6 repeats itself. Circle the 7, and there we go with the rounding stuff that's been explained to you on videos. And all sorts of different options. I mean, how about 3/4? These are called terminating, like 1/2, and that would be 0.570000. So these rational numbers have these special properties that the numbers under the hat, that is, the radicals that are not perfect squares, don't share. And it's really important to understand that at your age as we move along, working with these radicals that come up so naturally on these geometry problems. So I took the liberty of putting 1